Well, good morning, everyone. So today I will tell you something about scales. Why are we using scales? How to calculate the reliability of a scale and how to interpret those findings. Okay, werkt niet echt. Okay. In this course, you already learned a lot. You already learned about the relationships between independent and dependent variables, the whole logic about hypothesis testing, and how to choose the appropriate statistical analysis to test your hypothesis, depending on the type of variables that you have, and also depending on the type of hypothesis that you have. And today we will continue that with scales. And the positive news is it's only one command in principle that you have to use, and that is the alpha command. And in chapter 12 of your book you can read more about that. And while we treat this topic as last in this course, actually the alpha command and also factor analysis that we won't go into today, you should actually perform that before you perform the statistical analysis that you have to do to test your hypothesis. And why is that? Because the Cronbach's alpha, so to test the reliability of your scale, you have to do that before you do the statistical analysis. And that is because depending on the output of the Cronbach's alpha, you might adjust your scale. And that scale, that variable, you need that for your analysis. And if you have the wrong measurement, it's logic that maybe you will also get you will draw a wrong conclusion from the data, from the outputs out of your statistical analysis. Okay, so in surveys and experiments, we often use scales. Why do we use scales, and why don't we just use a single question to measure something? Well, because not everything can be measured with one single question. So if you want to know someone's age, you could just ask, how old are you? Then you get the number, that's exactly what you need, it's perfectly fine. But some constructs are a little bit more abstract and complex than just asking someone's age. For example, if you think about the construct trust or happiness. Let's see if you would measure happiness with one single item. So the item is, how happy are you on average? And then we have a scale from -5, not happy at all, to +5, very happy. Well, there are some disadvantages of asking one single question for this, and that is the first one. You only have 11 different scores from -5 to +5, and probably the extremes will not be chosen that much. So we cannot really differentiate very good between people. The second one is it's very difficult for people to estimate their own general happiness of, let's say, a whole year. So you have to fill in that item today, and today you're not feeling that good, and then you have to think about all the moments in the year, and you have to average that number. That's quite difficult, and then there will be a lot of noise, because maybe today you won't feel that good, so you will give a lower score than your real general score would be. And the third one is that, as I told you before, happiness is a quite complex and abstract construct, and it exists out of different pieces of happiness. So you can think of that happiness will exist out of different parts. For example, your general lifeline happiness, feeling ecstatically happy, but that also having good social relationships and not feeling depressed is also a part of happiness. And if you sum up all those bits, then you will come to the average happiness score of, let's say, a year. Well, in research, we usually refer to questions as items, and if you have multiple items to measure a construct, we refer to that as an item battery or scale. And if you see such an item battery, usually it contains positive formulated items, but also negatively formulated items. And that is because we want to double check if there are not people that just filled in the same score the whole time. And if you see that, you can decide to throw those persons out of your data set. Okay, so the general idea is that you have an item, and that item consists of 3 parts, and the first part is the true value. So that is the true value of the construct that you're trying to measure. For example, happiness in this case. Then it also exists out of the specific item value. So let's take the item, I feel happy in the mornings. So the true value is your general happiness. So you can imagine that if you are a happy person, you will also feel happy in the morning. Then the specific item value, if you're not a morning person, then you might still feel happy, but not super happy as like during the day or in the evening. So that will be the specific item value. And then you also have the noise. So for example, this week you really had a bad week, you slept awful, and then you will even score that item more negatively. And the idea is because you have multiple items that the noise and also the specific item value will average out, so that only the true value, so the happiness score, will remain. Yeah, something that we will disregard here today is such a concept can have multiple dimensions. For example, happiness can exist out of 2 dimensions. Let's say your general lifeline happiness and feeling ecstatically happy. And the idea is that if you can score high on one dimension while scoring low on the other dimension. So if you score high on being ecstatically happy because you like to go out a lot and every week you go out twice and you feel ecstatically happy then, but your general lifeline happiness is quite low. Well, then you have 2 dimensions. And we cannot test that with the Cronbach's alpha. You can test that with factor analysis. That's a more complex analysis, and you will get that in the next method course. So for today, we will just pretend that the scales we're treating today are one-dimensional. Okay, so an application of this idea can be found in the concept Wisdom of the Crowd. That's a book written by James Surowiecki, and the idea is that a large group of individuals often know more than just a few experts. And this idea is based on an observation of the scholar Galton, who went to a country fair, and he saw at that country fair that there was a competition, and the visitors of the fair were asked to estimate the weight of an ox. And 800 people participated, and if they look at the individual estimates of the participants, they saw that they were pretty off. They were not so good. But when taking the average of those 800 people, it was really, really close to the actual weight. So the idea is that even if people have no idea or just have like a small idea, if you average out that knowledge from a large group, then probably you will get to the right answer. And what do you need for that? First of all, diversity of opinion. So you need a large group of people that all have different backgrounds, so they all bring some knowledge to the table, but different knowledge. So you can also think about the items that I just talked about. You all need different items to measure the scale. And independent thought. So you should not mingle together and then discuss it and then come back with one number. Okay, I think this is the best estimate for the ox, because then you will have some people will be pretty dominant, other people claim to be experts, so then the idea doesn't work. Okay, the same idea, you can also see it in the TV show Who Wants to Be a Millionaire. We also have that in Holland. So there are different escapes if you don't know the answer. So the host asks a question, there are 4 possible answers, and one of the escapes is to ask the audience. So the audience can vote for the right answer, and people calculated this, and if the best answer is voted more than 50%, well, you have to choose it, because probably it's the right answer. And if there's a difference between 20% between the first and the second answer, also the advice is to take it, because probably it will be the best answer. Okay, let's see how this works. So even if you have an audience that's not so knowledgeable, they still, on average, can come to the right answer. So we have an audience, and we have 4 groups in that audience. So 20% of the audience knows it's answer B, for sure. Then you have 10% of the audience know it's not C and not D. So probably it's A or B. Then you have 30% who knows it's not D, so they think it's A, B, or C. And you have 40% that's just guessing. They have no clue. So there will be 20% for B, 5 on A, 5 on B, 10 also on A, 10 on B, 10 on C, and for the people that were guessing, also randomly divided. So if you sum up those answers, then you will get to the answer B, which is the correct answer. So even if you have an audience that doesn't really know the answer, still together you will come to the right answer. Okay, you did a test on Wednesday, or at least most of you did, I think, and it's interesting to see what were the most chosen answers on that test, and how well would you have performed if you had chosen the answer that was chosen the most the whole time. So you see here that a lot of time the correct answer was also the answer that was chosen the most. So, and I can already say that the general score on this test was a 6. However, if you had chosen the answer that was chosen the most the whole time, your grade would have been an 8.5. Okay, well, another where you also can apply that same idea is in sports competitions. So it wouldn't be fair that if someone participated in a darts competition by just throwing a single dart, we would decide who the winner is of that darts competition. So we would always let people throw multiple darts and play at multiple times against multiple people, and then out of that average, we will choose the winner. Okay, so the idea is if you have a large number of observations, even though there will be noise and coincidence, if you have a large group of people or if you have a large number of tests, the average is the true value that you want. Okay, is everything clear until here? No one has a question? Okay, well, we will continue with the measurement part. For a good measurement, you need a reliable and a valid scale. We will not go into validity today that much, but validity, of course, is that you're measuring the thing that you want to measure, and reliability is that you have a stable measurement. For example, if my weight would be 55, then if I would stand on a scale and every time it gives me the number 80 back, I stand on the scale five times and it gives me the number 80, then it's a very reliable scale, but it's not valid because it's not the measurement that I want, because I want to have my true weight. So of course you want to have the fourth image, you want to have a reliable and a valid scale. The concept about validity, you already got that in the first method course. Some validity types you can also calculate with data, but we're not doing that today. An example would be that if you would have a scale that measures if you have a healthy lifestyle, you would expect that would have a positive correlation with someone's BMI. So that's one way, for example, to check for validity. Then you have the concept of reliability. That is the one that we're going to talk about today. You have test-retest reliability. So you will test your scale today, and then you will test it next week again. And you would also expect that it would have a high correlation. If there was no intervention or something, at least you would expect the correlation to be high. Alternate forms of reliability, for example, if you have a 5-point scale and you would measure it again with a 7-point scale, then you would also expect that the correlation would be high, because a small change in your items, the answer possibilities, or even the formulation of the items, you wouldn't expect that the whole order of participants would be different. Inter-observer reliability, that is, for example, if you have an open question in your survey and you want to recode that question so you can perform some analysis on it, then of course it depends on my subjectivity as a researcher how I would code that question. So it is a good idea to also let someone else code the questions and then correlate the answers to see to what extent you agree about the coding. But we're not talking about that all today. Today we're going to talk about the internal consistency of a scale. So to what extent do all items measure the same thing? Okay, you all filled in a survey, and we're going to look at the happiness scale of that survey. We're not looking at the data of your data, we're looking at data of 2 years ago. So you can also perform these analysis yourself on the data set that you have. Well, the first thing that you have to do is not only look at your variables in the data set, but also look at the labels, or go back to the original survey. That's also possible. So look at the questions that were asked, and the first thing that you see is that there are some positive phrased questions and some negative positively phrased questions. And also look at the answer scale. So we see that a 1 stands for strongly disagree, and a 6 stands for strongly agree. Okay, then you perform the alpha commands. So that's just alpha, then you put in the names of the variables, feeling here. Then you will generate the scale score, generate happy, and then you write item. An item that produces this whole detailed table over here. If you don't put in the item command, then you will just get the alpha score. So the alpha score is this number. It's 0.82, which is very good. It's you want that alpha score to be high. Yeah, you want it to be high. The thing that I wanted to mention here, so if you generate, this command also generates the scale score. So that's an average score of those 17 feeling items for every participant. And it weighs every item the same way. So every item has the same contribution to happiness. You can also imagine that some items will have a higher contribution to happiness than others, but we will disregard that here. You will also get that probably if you are going to talk about factor analysis. And something that's important to note is that alpha also includes the missings. So if a participant did not fill in item 1 to 5, for example, then the skill score is also calculated for that person, but then just on feeling 6 to 17. Okay, what is the Cronbach's alpha? You can imagine that if you would split the items in half, so the first 9 items and the last 8 items, and you would correlate those sets together, you will have a high correlation. If the items all measure the same thing, the correlation would be high. So if you do that in all possible ways, and then you average out that number and correct it, then you will get the alpha score. There's also another definition that's a little bit more abstract. You can read about it in your book if you're interested in that. The rules are that an alpha above 0.90 is very, very good. Between 0.70 and 0.90 is also good. And above 0.6, everything above 0.6 is acceptable. And below 0.6 is poor and not acceptable. You don't want that. Oh yeah, and this Cronbach's alpha has nothing to do with the 5% significance level. Okay, now we're going to look at the table. In the column sign, well, you will see the sign, obviously, a minus or a plus. And what Stata automatically does is give the sign to the variables. So you don't have to recode your variables. It automatically gives the sign. And that is based on, okay, if they would give a variable a negative sign, and if that would increase the alpha, then Stata would give it a negative sign. But you should double check this, if this is correct, if Stata gave the right signs to your variables. Then in the column next to it, it's the item test correlation. That is the correlation of the specific item with the scale score. And for example, if you would expect feeling 1 to have a contribution to the total happiness scale, if it would measure happiness, then of course you would expect the correlation to be high. Then the column next to that, item rest correlation, is actually almost the same. Of course, if you calculate the correlation between feeling 1 and the scale score, feeling 1 is also part of that scale score. So there will always be correlation. So actually this is a little bit a more pure calculation because it is the correlation of feeling 1 with the scale score minus feeling 1. However, the numbers will be a little bit lower than the column before, but the order will more or less be the same. Then the column next to that, average inter-item covariance. Well, in practice you won't be using that, so we'll disregard that here. The last column, alpha if item deleted, is a very important and easy to read column, because there you will see the alpha value if that item was deleted. So let's see, if you look at feeling 4, you see that the alpha score would be higher of your scale. So if you delete item 4, then your alpha score would be higher. Well, now we're going to look at what is that feeling 4 then. Okay, so feeling 4, I rarely wake up feeling rested. Well, if you think about it, you can imagine actually that maybe wake up feeling rested is maybe not such a good item to measure happiness. Because maybe you're just not a morning person, or you like to go out a lot, and feeling 4 was maybe a better representation of feeling rested than of feeling happy. Because you might be very happy, but just not a morning person. Yeah, here's the command for if you don't want Stata to change your signs. So I just talked that Stata automatically change your signs, but that can also be incorrect. Most of the times it will be correct, but it can be incorrect. Then you can type in as is. And as I told you before, the alpha command will generate a scale score for everyone, independent of the number of items that you fill in. But you can also say that you only want to have a scale score for everyone that filled in, for example, a minimum of 5 items. So this is the command for that. Well, if you want to improve your scale score by excluding items, there are some things you have to do. First, consider which items fit least. So you can do that with the column alpha if item deleted. Then look at the item. Do you understand why that item is maybe not such a good fit for your measurement? And then also, if the difference is not that big, by deleting that item, you can also, because in principle, if you're referring to an existing scale, in principle, we want to keep that existing scale. So if the difference in alpha is not that big, you might consider not deleting that item. Okay, we're now going to look at an exercise, how that works if you delete an item. Okay, so if you look at this, then we might delete feeling 4 and feeling 17, because if you delete those 2 items, then the alpha score will be higher. And you see that the alpha increased until 0.85 by deleting those 2 items. So you might consider doing that. You can also do it another way, because we just deleted 2 items at the same time, but you can imagine if you would delete 1 item, that will also have an effect on the other values. So now we're doing it one by one. So first we're deleting item 4. And then if you look at it again, it's not 17 that should be deleted, but 12 should be deleted. So you get a higher alpha score. So we are going to delete 12. And now we have to delete 17. And now we have to delete 5. And now 11. So you see, if you do this one by one, and now 8. now we have to delete 1. So, and now we're done. So it's the same scale, and if you deleted 2 items in one time, it was fine. There were no items that you could delete, and the alpha would be higher. But if you would do it one by one, then we could continue this process until we deleted 7 items. And now the alpha is actually the same, also 0.85. However, as I told you, in principle, we want to keep the existing scale, and if we only increase the alpha just a little bit, from 0.81, I believe, of 0.82 until 0.85, well, we might consider not deleting all those items. However, if you had an alpha score of 0.6, and by deleting 7 items, you could increase it until 0.85, then definitely do it. However, with this, it's a little bit debatable what you should do. There's no right or wrong answer. So you might not like to hear that, but that's the truth. So the most important thing is that you can argument why you chose the thing that you chose. There was also another scale in your questionnaire, and that was about trust in foreigners. Well, if you look at...
I see that only the plus signs are left over, so maybe it's in the way questions are... I see only signs...
Yeah, that's interesting.
So maybe it's just because people who negative formulated questions deal with it in another way.
Yeah, that's interesting. Yeah, we have to take a closer look at that, why that might be. But indeed, there can be a difference between the negatively phrased questions and the positive phrased questions. I don't know, Chris, do you have something to add to that?
Well, it happens. Okay, so we're not looking at sub-dimensions of an existing scale, but what happens quite often that if you would, then every once in a while the positive ones and the negative ones turn out to be 2 separate parts of the scale. So this does happen every once in a while. And I don't know by heart exactly what the other ones that were left out now were measuring. But normally that's the first thing that I would do. Just look at what the content of the things is, and then you might see that they're not only all negative, but all about being a morning person or who knows what. Yeah,
I know one is I feel depressed, so that can maybe measure a little bit different thing. I have to go way back to the items. I don't feel particularly pleased with the way I am. I rarely wake up feeling rested. I'm not particularly optimistic about the future. I do not think that the world is a good place. I don't look attractive. Maybe it's measuring depression. Can be because they're negative, can also be because it just measures another concept. So this was the scale with the trust in other countries, and this is great if you have this result, because there are no items that you should delete, and the alpha is very high. The only thing is you have now 13 items and you have a very high alpha. So for the next time, if you will use this scale, you might consider just taking 10 items, for example, because then probably the alpha still would be high. Well, why is it a good idea to average out your score and generate a skill score? And that's also useful for your statistical analysis. So if you would perform a regression analysis, and here we did a regression with the variable net income. That was the question in the questionnaire. How much do you think you would earn if you are 30 years old? And then with all the independent feeling variables. Well, if you do that, you see that hardly any of the variables are significant. There's only one item that has a significant contribution, but for the rest, nothing is significant, and then your conclusion would be, no, how you feel now, if you're happy or not, it doesn't matter for your perceived income. However, that is because in the regression analysis, it looks only at the net contribution of each variable. So it looks at the contribution of feeling 1 next to all the others. And the net contribution of feeling 1, well, that wouldn't be that much, because you also have feeling 2 to 17 in there. So if you now would calculate the skill score, and you will use the skill score, so the happiness score in a regression analysis, you do find there's a significant positive relationship between happiness and your perceived income. Well, if you looked at it closely, you did saw that the explained variance in the first model was bigger though. So if you want to predict something, then you might put in all the separate variables. However, because we are social scientists and we usually want to understand a relationship and explain a relationship, we usually use the skill scores in our regression analysis. Okay, well, we just talked about a scale that had the same answer possibilities for every item. So the scale was from 1 to 6. You can also imagine that you want to produce a scale and of which the items have different measurement units. Well, if that is the case, you should standardize the items. This is standard data of Stata, and it's car data. And you will see that the car data exists out of different variables that all have a different measurement unit. So you have the trunk, and that's probably in cubical centimeters. The weight can be in pounds or kilos. The length can be in centimeters. So every variable has a different measurement unit. And if you will perform the alpha command on these variables, by not standardizing, the alpha value will be very low. It will be 0.27. However, if you would standardize the items first, then you will see you have a very high alpha score of 0.95. Yeah, something that you should know is that the alpha score gets higher if the correlation between the items is higher, which is good, that's what you want, but also if the number of items is higher. So if there is a very low correlation between the items, but you have 50 items to measure something, then the alpha also will be very high. And there's also no good or bad in this. Maybe you need 50 items to measure your measurement construct, but it is something that you should know. And well, if you have decent correlations between your items, then usually a scale of 10 items will probably will be enough. Yeah, if you have a high alpha score, it does not imply that you have developed a good scale. So it's good that if you have a high alpha score, but it does not imply that you have developed a good scale. And this is an example. For example, if you want to measure social cohesion in a neighborhood, and you develop 3 items. We are very close in this neighborhood. I am very close with my neighbors. We know each other very well in this neighborhood. Well, I didn't calculate the true alpha because I made them up. But those items, will probably have an alpha score like around 0.95, because yeah, it's almost the same item. So if you will answer a 5 on answer 1, you will probably also answer a 5 on item 2. But it's not a real good measurement of the construct. So better would be if you have a diverse set of items that all measure a part of that social cohesion, even though the alpha score will be lower than. A high alpha also does not imply that you only have a one-dimensional construct. So if you have 10 items and 5 items measure anxiety and 5 items measure depression, then probably you will have a high alpha score, because depression and anxiety are related to each other. They have a high correlation. But if you will perform factor analysis, a more complex analysis, then you will see how many dimensions your construct really has. And after you performed your factor analysis, then you have to do the Cronbach's alpha, the reliability analysis again. But we're not talking about factor analysis today, but it's something that you should know, that a high alpha does not mean you only have one dimension. Something that you should also know is that for the alpha, you can also calculate the confidence interval, so that is the true value of the alpha in the population. And here you will see the true value will be somewhere between 0.80 and 0.87. And you can do that with this bootstrap command. Should we do the break? Ja, 5 minuten denk ik, 10 minuten. Okay, I will just finish the story and then afterwards you will have the break. It's, I think, 5 or 10 minutes more. We would like to challenge you to try this command and these commands on your own data set. So the skills that I talked about today are also in your own data set, and maybe different output will come out, because this is another year. Well, sometimes you have to create your own skill. For example, for your master project or your bachelor end project or other project, you want to research something and you have to use a skill. Well, what should you do then? Well, don't try to come up with your own skill, because there will be a lot of work to do that. You have to formulate items, you have to talk to experts, you have to validate your skill, you might want to test it again. So it's better to first check if someone else already developed the measurement construct that you want to use. So just go on Google Scholar or in the TUE online library and just check if someone else already had created a skill. And then probably you will find more hits. So you will see more people have created a skill, and then which one to choose. Well, here are some criteria that you can look at. Well, first, look at the skill that will fit your construct the best. So, which is similar to the construct you want to measure. Then also look at the reliability and validity scores, if they are available, and see how good they are and how often it is tested. It's also interesting to see how often that skill that you want to use is used by others or referred to by others in the field that you're studying. And some practical thing is look at the number of items. So if you already have a big questionnaire with 50 questions and you want to add a scale, don't add a scale with 30 more questions, for example, because that will reduce the reliability of the answers, because people have to fill in a very long questionnaire. So then you might consider by choosing a scale that has a little bit less items. And if you cannot find exactly what you need, then you might consider adapting an existing scale. There's an example here of the scale vulnerability. That's how vulnerable or how high do you perceive the risk of hypoglycemic is. And Shitaro, who did research on emergency landings in virtual reality, he just adapted that existing scale by just only changing the topic. The alpha score is lower though, but it's a good idea just to change the topic. Okay, well, so the skills are important for your research. Also at HCI, we use a lot of skills in our research. An example of that is I did a recent study with virtual reality in which I placed people in a burning house. And I measured afterwards to what extent they feel immersed in that virtual reality environment, because I expected if people felt more immersed in that environment, it will have more impact on them and it might motivate them to buy a fire blanket. But we're also trying to measure those concepts in a more indirect way. So we're trying to measure also heart rate variability or sweat conductance or other things that can say something about your behavior or how you feel. Okay, so in summary, complex abstract measurements are not measured with one single item, but can be measured with scales, also referred to as item batteries. And that is a better idea, because then you will have multiple items to measure something, and that will average out the noise. And the reliability of such a scale can be measured with the Cronbach's alpha, and the command is here on the slide. And important to know is that the alpha does not test the one or multi-dimensionality of a scale, but that can only be tested with factor analysis, and you will have that in the next method course.